Hi friends, welcome back to the continuation of this continuity and limits chapter. We have already seen as to how to understand the definition of a function from the relations, and we have also learned these Cartesian products. From the Cartesian products we made relations, from the relations we made functions, and then we also learned how to check the continuity of a function at various limits. Also, we learned various types of discontinuities: jump discontinuity, removable discontinuity. This type of discontinuities we have seen. Also, when a function is approaching infinity, how it appears, that also we have seen. So today, in the same continuity chapter, limits and continuity chapter, I would like to derive very important derivation called as limit limit x tends to 0, sin x by x is equal to 1. This is a very important derivation. Let us see. Step by step, I will teach you so that you can also note down. Yeah. Now, before going to the derivation, this derivation requires three important geometrical formulae, or you can say concepts. One is called as, from a right angle triangle, sin x or sin theta, whatever is there, is called as opposite side by hypotenuse. This formula we should know. For example, this is right angle triangle. At B, we are having right angle. Let us angle B is 90 degrees. This is, let us say, x. Angle is x. Then what is sin x called here? Opposite side. For angle x, opposite side is AB and hypotenuse is AC. So we can write here AB is equal to AC sin x. Suppose if I want to write for cos x is called as, for this angle, adjacent side is BC. BC divided by AC. So we can also write BC is equal to AC cos x. So this particular memory from trigonometry is required. Second one is called, let us say, sector. You learned this in mensuration. If you are having a sector with an angle, let us say x, OAB, we have to only remember here what is the area of sector formula, because our derivation requires these two. Area of sector whose radius is r and included angle is x is given by half into r square into x. Half r square x is called as the formula. So these two I will be using in the derivation. That's why I first introduced here. Let us go to the derivation now. To do this derivation, we have drawn a picture here. One circle we have taken. In this circle, we have noted down some points. So step by step, I'm writing here. Consider, let us consider a unit circle. Let us consider a unit circle. What is unit circle? Unit circle is nothing but a circle whose radius is 1 unit. Unit can be in centimeter, 1 meter, 1 kilometer. That one stands for unit. Let us consider such a unit circle. Let O be the center. Let O be the center. Then join OA and OB. So you have to mark 2 points AB on the circumference. Join them to center, OA and OB. OA and OB, what they do? They form radii of the circle. Okay, understood now? So we have taken 2 points on the circumference, A and B, joined to O. So we got 2 radii, OA and OB. let angle AOB be x radians. This is the angle now. You can put degrees, radians, but this derivation mainly works for the they put radians here, angle x is equal to. But even if I put theta degrees also, I don't think any problem will arrive. So x radians we will take. As per the textbook only we will do. Then what I do now, here some small geometry I'm doing. What I'm doing, draw perpendicular BD to OA. Then next step what I'm doing is I'm joining B to A. I'm joining B to A. Then what I get now after joining here, if you observe clearly, join BA. Then I got one triangle. If you observe OAB, I got a triangle. Then we get a triangle OAB. Understood? No? Next, draw a perpendicular. Draw a perpendicular AC at from A. You observe this now. This line is a perpendicular. Then produce OB to meet perpendicular at A in C. Understood? No? The perpendicular what I have drawn and this produced ray or line both are meeting at a point called C. Then what you got? Again, I got one more triangle. Triangle OAC is formed. Okay, now there are two triangles. One is called as OAB, another triangle OAC, and then there is, if you just carefully observe, sector OAB. Now there is a sector OAB in the circle. Understood? No? Now OAC, OAB and sector OAB. Triangle OAB, sector OAB and triangle OAC. I'm writing clearly triangle OAB, comma, triangle OAC and sector OAB. Followed now. Better what I do, I will write this sector in the center so that it will become easy for you later. Sector OAB and triangle OAC. There are three geometrical figures I am writing here. By visual observation, you can see very clearly that triangle area is small compared to sector area. Is it not? Sector is occupying little more area. It is within circle. Even then, this triangle is occupying little lesser than the sector from this diagram. Compared to these two, this triangle is much bigger in area wise. So now what I am trying to do, I am comparing the areas of these three. Comparing the areas of above three figures. So what we'll get now? I can write very clearly. What I can do now, by comparing, I can tell that triangle AOB is less compared to Let me see what notation we have written in the previous page. OAB we have written for a triangle. OAB we have written for sectors. So better we use same thing. Instead of writing triangle AOB, I will write here OAB. Sector OAB is less than triangle OAC. Okay. Now, triangle OAB, if you see the previous page, you can very clearly say that area of a triangle is half into base into height, half into OA into BD. BD is called as the perpendicular we have drawn, which is nothing but altitude. So for this OAB triangle, OA forms the base, BD forms the perpendicular. For the sector, half into, we have seen the formula in the first page. Half into radius is OA, OA into OA into X. X is called as the angle. Then less than OAC formula, half into OA into AC. AC is called as the perpendicular. Now, in all these three, what is common? Half is common. Score it off. What is again common? OA is common. Score this. So you are left with only now BD is less than OA into X less than AC. Now, what is this BD? Let us go to this page once more and see what is this BD now. Sin X is equal to BD by OB. Sin X is equal to BD by OB. Correct? BD by OB. So now you can write this as even BD by OA also, no problem, because OB and OA both are same for us. So cross multiplication will give me, by writing so, sin X is equal to BD by OA. Then OA sin X will become BD. So I write here OA sin X less than OA X, this one AC. Go to the previous diagram. This is AC for you now. What is AC here? Cos X you observe. Cos X is equal to OA divided by tan X. I do not work cos X, tan X. Sorry. Tan X is equal to AC divided by OA. That will write down from this diagram. From triangle OAC, tan X is equal to OA divided by AC. So this will become AC tan X tan X is equal to AC by OA. That only we are writing here. AC by OA. No, just I'm correcting here. Yeah, tan X is equal to AC by OA, not OA by AC, sorry. So then from here, AC will become, from this, AC will become OA tan X. Okay. OA tan X. Again OA cancel. Now you divide throughout by sin X. Divide by sin X throughout. What I'll get? Sin X by sin X, X by sin X, tan x by sin x. Okay, sin x by sin x by sin x, tan x by sin. So sin x and sin x you cancel. You'll get 1 here. This is x by sin x less than tan x means, you know, it is nothing but sin x by cos x. This sin x is in the denominator already present. Again, this sin x you cancel. 1 less than x by sin x less than 1 over cos x. Okay. So now what I do here, I will take the reciprocal. Taking reciprocal. 1 will become 1 only. Reciprocal of 1 is 1. X by sin x reciprocal, sin x by x. 1 by cos x reciprocal, cos x by 1. So when I'm taking reciprocals, I must change this less than symbol to greater than symbol. So I remember that. So first 1 greater than sin x by x greater than cos x. This is what we are having. Let us say I will write this ulta. Then what happens from this side? Cos x sin x by x greater than cos x means cos x is less than sin x by x. This is less than further. What is number 1? Now we'll put till x tends to 0. What you are getting now? Cos 0 less than sin x by x less than 1. Cos 0 value is 1. Sin x by x less than 1. What does it mean? As you are going tending limit x to 0, sin x by x is tending to 1. That is the meaning of this. This side also 1 you got, left hand side, right hand side also tending to 1. So sin x by x, the meaning of this is, this implies sin x by x will tend to 1 as x tends to 0. So this is the derivation of limit x tends to 0, sin x by x is equal to 1. So carefully, step by step, you have to see this. Only main secret or clue here is you have to draw 3 geometrical figures. One is called as a triangle OAB, then one sector will be there, and one more triangle OAC. We will compare the areas of these 3 geometrical figures, and then we will try to cancel out the identical terms, then take the reciprocals, and then finally we will rearrange the terms, apply the limit x tends to 0. Then what you get? You will be getting cos x less than, cos x less than sin x by x less than 1. So limit x tends to 0 here, cos 0 less sin x by x less than 1. That means sin x by x value here between 1, both sides 1 is there, means the value of sin x by x is 1 when x tends to 0. So friends, hope this derivation you have understood. Any doubts are there, you can ask me. And then in the columns also you can leave any column, any concept or any problem if you have not understood. Thank you.